Welcome to the fifth and final lesson in Session 4, Rational Exponents. An exponent that is written as a fraction represents a radical. For example, we have a to the m over n power, and that translates into radical form as the nth root of a to the m power. So again, a to the m over n power translates in radical form as the nth root of a to the m power. So if you follow a, the base of the exponent, when translated from exponential form to radical form, goes from the base of the exponent to the radicand of the radical. The numerator of the rational exponent, n, translates as the exponent in radical form. So it's the numerator of the rational exponent in exponential form represents the exponent in radical form. Now the denominator of the rational exponent, in this case the variable n, translates to the index of the radical. So the variable n is the denominator of the rational exponent in exponential form, translates to the index of the radical in radical form. So here we're going to translate a few expressions from exponential form to radical form. So we have 25 to the 1/2 power. So when translated into radical form, that's the second root, so it's the square root of 25 to the first power. So we don't write the index of 2, and we don't write anything to the first power. So 25 to the 1/2 power is equal to the square root of 25. So what you want to walk away from this example is anything raised to the 1/2 power is exactly the same as taking the square root. Next, we're going to take 8 to the 2/3 power. So when we translate that from exponential form to radical form, that is the cubed root of 8 to the second power. So the cubed root of 8 is 2, and then 2 to the second power gives us 4. Now we're going to go over a few examples and simplify each one. So the first one, we have 64 to the 1/3 power. So that's equivalent to the cubed root of 64. And the cubed root of 64 is equal to 4. 4 times 4 times 4 is equal to 64. Next, we have 7 to the 1/2 power times 7 to the 1/2 power. So we're going to employ the same base rule, the same base property of exponents, where when you multiply exponents of the same base, we add the exponents. So that gives us 7, 1/2 plus 1/2 is equal to 1, 2 over 2 in this case. So 7 to the first power is equal to 7. Next, we have 5 to the 1/3 times 25 to the 1/3. So notice those do not have the same base. 5 and 25 are different bases, so we can't simply add the exponents in this case. What you do understand is 25 can be expressed as a base 5, because 5 to the second power is equal to 25. So I rewrite 25 as 5 to the 2/3 power. So 5 squared is 25, so we can translate that. So we have 5 to the 1/3 times 5 to the 2/3, which adds 5 to the 3/3, giving us 5. Next, we have negative 27 to the 2/3 power. That's going to translate to the cubed root of negative 27 to the second power. Now, since we have an odd index, the negative underneath the radical does not create any problems. Only in square roots and fourth roots and numbers where we have an even index, we cannot have negatives underneath the radical. But with a cubed root, that's perfectly acceptable, because negative 3 times negative 3 times negative 3 is equal to negative 27. So we have negative 3 raised to the second power, which equals 9. Last example, we have 25 to the negative 3/2 power. So remember, negative exponents produce fractions. So when we translate this into radical form, we have the square root of 25 to the negative 3 power. So the square root of 25 is 5, and when we raise 5 to the negative 3rd power, we get 1 over 125. The 125 comes from multiplying 5 times 5 times 5, and we have the reciprocal because we have the negative fraction. So 5 to the negative 3rd power is 1 over 125. So that wraps it up for session 4. Make sure you complete the quiz and the test in order to receive credit for completing this lesson and this session. Good luck, and email us if you have any questions.